everyone. Welcome back to ZTech Advisor. Today, we're diving into the exciting world of public key infrastructure, PKI. First off, let's talk about what PKI is all about. It's a computer security system that authenticates users and devices and encrypts data. It also plays a vital role in managing digital certificates, which are used to establish trust between entities in secure communications. What is PKI? PKI refers to the set of tools and processes used to create, manage, and distribute digital certificates too. These digital certificates cryptographically link a public key with the device or user who owns it too. This helps to authenticate users and devices, ensuring secure digital communications too. Why is PKI important? PKI is crucial because it manages and enables trustworthy, secure communication online. For an enterprise, PKI can make the difference between an intruder gaining access to the network through a connected device and keeping a potentially dangerous threat away from the organization. How does PKI work? PKI works through the implementation of two technologies, certificates and keys. A key is a long number used to encrypt data. With PKI, there are two keys, a private and a public one. The public key is available to anyone who wants it and is used to encode a message that someone sends to you. A private key is what you use to decrypt the message after you get it. The keys are connected using a complex mathematical equation. Certificates, which are issued by a certificate authority, CA, let you know the person or device you want to communicate with is actually who they claim to be. When the correct certificate is associated with the device is considered authentic. Trust models. Understanding trust in cryptographic systems. Trust is a crucial component of any cryptographic system. To ensure secure communication, it's essential to confirm that two people are genuinely communicating with each other and not an impersonator, while also preventing eavesdropping on their encryption key exchanges. The Diffie-Hellman key exchange protocol helps prevent eavesdropping, but verifying the authenticity of the communicating parties is still necessary. In asymmetric cryptography, each user has a private key, which remains secret, and a public key, which can be shared openly. Public keys help eliminate eavesdropping risks, but the challenge remains in confirming the true identity of the public key owner. Methods to establish trust. There are three main methods to ensure the authenticity of the communicating parties. 1. In-person key exchange. Description. This method involves physically meeting to exchange keys. Imagine you and your friend meeting in a coffee shop and handing over a USB drive with your encryption keys. Challenges. This approach is cumbersome and impractical, especially for large organizations or when the parties are located far apart. 2. Web of Trust. Description. Introduced by Phil Zimmermann with the PGP encryption software, the Web of Trust leverages indirect relationships. It's similar to social networks like LinkedIn, where you may not know someone directly, but you might know a mutual friend who can vouch for them. How it works. Participants sign the public keys of individuals they trust, creating a network of trust. For instance, if Alice trusts Bob and Bob trusts Charlie, Alice might trust Charlie based on Bob's recommendation. Challenges. Decentralized management. It's difficult to manage trust relationships on a large scale. Barrier to entry. New users need to build trust relationships from scratch, which can be time-consuming. Technical knowledge. Users need a good understanding of cryptographic concepts to participate effectively. 3. Public key infrastructure, PKI. Description. PKI builds on the Web of Trust concept but introduces centralized authorities, known as certificate authorities, CAs, to simplify the process. How it works. Certificate authorities, CAs. These trusted entities issue digital certificates that validate the ownership of public keys. For example, when you visit a secure website, the site's digital certificate, issued by a CA, ensures you are communicating with the genuine website. Digital certificates. These certificates contain information about the key owner and their public key, authenticated by the CA. Web vantagens. Ease of management. The centralized approach is easier to manage compared to the decentralized web of trust. Widespread adoption. PKI is widely used in various applications, such as secure email, online banking, and web browsing. Real-life application of trust models. Case study. Email communication security. Imagine a global company, TechCorp, with employees scattered across different continents. Secure email communication is vital to protect sensitive information. Initially, TechCorp tried using the web of trust. However, managing trust relationships among thousands of employees became a logistical nightmare. To solve this, TechCorp implemented a PKI system. They set up a CA that issued digital certificates to each employee after verifying their identity. Now, employees can exchange emails securely, knowing that the digital certificates assure the authenticity of the sender and receiver. For instance, when Emma in New York sends an email to Liam in London, she can be confident that only Liam can read it. Example: web browsing and SSL/TLS. When you visit a secure website, your browser relies on PKI. The website's SSL/TLS certificate, issued by a trusted CA, ensures that you are communicating with a genuine website and not an imposter. This trust model is crucial for e-commerce sites like Amazon, where secure transactions are essential for customer trust and business operations. When you enter your credit card information, the SSL/TLS certificate ensures that it's encrypted and sent only to the legitimate website. Scenario: secure online consulting with PKI. Let's say you're seeking tech advice online at a popular consulting website, www.ztechadvisor.com. 1. Certificate issuance. Before www.ztechadvisor.com went live, the website owners applied for a digital certificate from a trusted certificate authority, CA. The CA verified the identity of the website owners and the legitimacy of the website, then issued a digital certificate. 2. Secure connection. Now, when you navigate to www.ztechadvisor.com, your browser requests the site's digital certificate. The website sends it over. 3. Certificate verification. Your browser checks the digital certificate to ensure it's valid. It's been issued by a trusted CA, and it matches the website you're trying to reach. This process is invisible to you, but happens in the background. 4. Secure communication. Once the certificate is verified, your browser uses the website's public key, included in the certificate, to set up a secure, encrypted connection. This ensures that any data you send to the website, like your personal information, can only be decrypted and read by www.ztechadvisor.com. 5. Data transfer. Now you can safely browse the website, seek advice, and enter your personal information, knowing that your data is securely transmitted to www.ztechadvisor.com. This is a simplified example, but it gives you an idea of how CAs and PKI work together to secure your online consulting experience. In reality, the process involves more technical details and additional security measures. Conclusion: trust models are fundamental to cryptographic systems. Whether using the web of trust or PKI, the goal remains the same: ensuring secure and authenticated communication. While the web of trust is valuable, its complexity limits widespread use. PKI's centralized approach provides a more practical and scalable solution, making it the backbone of modern secure communication systems. Next time you send an email or visit a secure website, remember that these trust models are working behind the scenes to keep your communication safe and authentic. That wraps up today's lesson on public key infrastructure. I hope you found it fascinating and enlightening. Thanks for tuning in, and don't forget to hit that like button and subscribe for more exciting tech content like this one. See you in the next video.